Today, we are starting off by graphing these things. Now, obviously, I have an advantage because they're on my screen, and you don't necessarily have that, but you can make do. What would these graphs look like with restrictions? So my first one says r equals 2. Show me with your arms, what does r equals 2 going to look like as a graph? Just regularly, what would the graph look like? It's a circle, right? Because r is radius, your radius is 2. It's a circle. So your normal graph would look like this. You would go to where your radius is 2. If you have this graph, it's pretty easy to do. All you got to do is draw a circle, but actually draw it on the circle. Oh, that's close enough. Make sense there? But that's not what it says. It says I'm graphing this with restrictions. My theta needs to be between negative pi over 2 and pi over 2. Anybody have a guess as to what they think the actual graph will look like if my restrictions are negative pi over 2 to pi over 2? Kara? The right half of the circle. Why is that? Yeah. Good. That's negative pi over 2 there. That's pi over 2 there. She's picking all the places in between there where the radius is 2. And so it would be all of that guy with a regular line. I'm just making it easier to see. But there's my graph. Kind of makes sense why we got that? Yeah. Question, Megan? Well, I'm between negative pi over 2 to pi over 2. So what's a number that goes between negative pi over 2 to pi over 2? 0? 0 is between a negative pi over 2 and a pi over 2, right? And so the values that are between negative are all on the right side. That's why it is what it is. Good. Let's graph it. Pull out your graphing calculator. So we can graph all of these things on our graphing calculator. It'll make sense as we go. Hit the mode button. What do you think you need to change on your screen to graph polar? Pole. You want to go to polar. So depending on your calculator, it might say different things. But on mine, it says the word polar. On a lot of yours, it'll say POL. That is the mode you want to be in. You also want to make sure you're in radians. So make sure those two things are true. Hit enter. Get second quit and get out of that screen. Okay. So I'm back to here. I'm in on my calculator. You can see I'm in radians up there on the top, and I'm in polar. Now hit the y equals button. See how that's different? It doesn't say y equals anymore. Now it says r equals. We are going to graph r equals 2. So put the number 2 in there. Then just so we're all on the same page, hit the zoom button and change your zoom to zoom 6. Someone said ooh, and that is the correct answer. This is gross. I hate this about all pictures. It's like when you took a picture on the internet. Have you ever seen a picture that's been like badly stretched? It's awful. I hate it. That's what's happening here. Okay? Because what we did is we changed the window from negative 10 to 10 and negative 10 to 10. So we can fix that. What is this supposed to look like? It's not there. So hit the zoom or hit the window button. Theta min, theta max. We'll come back to that in a second. Let's go to y min and y max. That's the thing that's stretching us. You can change this number. There's different things you can do. Let's go with like negative 6.7 to 6.7. That's kind of the closest. Sometimes you can just type in 6 or 7, but hit that instead. Now we hit graph. A little better. Okay, not the terrible circle that we had a second ago. Everybody kind of makes sense what's going on? Depending on your calculator, it might not look that clean. Jake, does yours look, you said looks more octagonal? All right, so there is something you could do with that. Now, I don't suggest you doing it very much, but you can. There's Theta Step. Okay, Theta Step is how much in between does it take to graph. The smaller the number here, the prettier your picture is going to look, but it's also going to graph significantly slower. Okay, so like I don't do this on your calculator, or it basically breaks it. But if I go 0.005, for me, it's pretty simple, but it's going to make it less boxy, okay? I would suggest making it like 0.1. If you want to get crazy, go like 0.05. 0.1 is going to be a normal speed, but that's it's going to tell you the speed. You can see that graph isn't quite as good as the other one, but it's close. Makes sense to there. Hit the window button again. But in the bell work, we were graphing it between negative pi over 2 and pi over 2. So let's change our theta min and our theta max. For theta min, I'm going to type in negative. Make sure you're using the negative button. So as I go here to theta min, use the negative button. Negative pi over 2. And I'm going to graph to pi over 2. Hit the graph button. It did what we thought it was going to do. Okay, it was a little semicircle on the right side of my graph. Everybody go with what's happened so far? Yes. Let's go back to bell work. Back on bell work now, we've got r equals negative 4 cosine theta. You are not an expert on polar graphs yet, so you might not know what that looks like. But what we can do is do a little bit of conversion. Eventually, we'll be able to just graph it without converting it. But let's say we don't have that skill set. Let's rewrite it. So r equals negative 4 cosine theta. I don't know how to graph it with r and theta, so let's change it to make it x and y. What substitution could I make to make this x and y? Cosine is x over r, so I'm going to do that. Make it x over r. Then what? Multiply both sides by r. That cancels. I get r squared equals negative 4x. We're getting a little bit better. Then what could I do? Substitute Pythagorean theorem. X squared plus y squared equals negative 4x. What shape is this thing going to be? It's a circle. You got x squared and y squared. It's a circle. We got to get it in standard form. So you got to move that negative 4x and go from there. If you haven't done that yet, do it now. Go. Here we go. Show me with your fingers. What number did you put right here after 4x? You would put the number 4 because you take this number, you cut it in half, and you square it. That goes there. And whatever you put on one side, you put on the other side to balance your equation. Then we are writing it in standard form. So it's x something squared plus y squared equals 4. My screen just died. X squared plus y squared equals something 4. Then all I got to do is fill in the number with my x. Show me with your fingers what number goes with your x. It's 2 because you're factoring this guy right here. It factors into x plus 2 and x plus 2. Or just take that number, cut it in half. So it's a circle. Point. Which direction am I moving to graph the center of the circle? Left, because it's with my x. I move that direction and I change the sign. So plus 2, I'm going left 2. That is the center of my circle. What is the radius of my circle going to be? It's 2, right? Because it's 4, so we do that. So it's a little bit weird up here, but look what I'm going to do. I'm going to go right 2 and left 2, and then I'm going to graph a circle the best I can. Oh, no. Oh, no. Oh, it's close enough. Thank goodness for fixing stuff. All right. It's fine. Act like it's good. Oh, no. This is going poorly. All right. Everybody good to there? Now, that's the graph. The question, though, was what is this graph going to look like if I graph it between 0 and pi over 2? Talk about that with your neighbor for a second. What do you think the graph's going to look like? What do you think the graph is going to look like if I graph this thing between 0 and pi over 2? Nothing. Okay, because I'm guessing a lot of you are thinking, oh, if I look from 0 to pi over 2, there's nothing in this part of the graph. And that's a good idea to have. It's wrong. Let's see what it would really be. Okay, so let's use our handy dandy calculator and figure out what's going on. We're going to y equals. We're going to type that thing in. Remember, it is negative 4. Make sure you're using the negative sign. Negative 4 cosine, and then it's theta. Okay, I found in my last class is using the wrong button. This is the button you are using. See how this button has an x, a t, a theta, and an n. That is always the variable you use when you're graphing. Okay, so negative 4 cosine theta. It automatically changes to theta since we're in polar mode. Okay, we type that in. We hit the window button. Our window needs to be between theta min needs to be 0. Our theta max needs to be pi over 2. Hit graph. What? What? That is not what we thought it was going to be. It told us that my graph is this thing right here. It's this little bottom half of this circle. Let's look at why. Okay, so understand what we're doing. If you don't know, let's plug in some numbers. It is -4 cosine. What would be a good angle to plug in? We're going from 0 to pi over 2. So a good number to plug in would be 0. Okay, so let's plug in 0. So it's -4 times, what is cosine of 0 going to get me? Cosine at 0 would get me 1. And so what we just found out is my radius is going to be -4. So think about that. My angle is 0. My radius is -4. So here is where my radius would be 0 right here. I'm sorry, where my angle would be 0. But my radius is -4, so I would run across to that side right there. That is where the starting dot is going to be. It's not in that quadrant because I had a negative radius and moved it to a different quadrant. It looks different than it actually is. Kind of makes sense on the first one. Let's do the next one. What's another good angle to plug in? 40, yeah, let's go pi over 4. 45 degrees. So it's going to be -4 times, what is cosine at pi over 4 going to be? √2 over 2. So my radius is going to be -2 √2. What is that going to get me? Well, I don't know. -2 √2. Hit enter. -2.8. Okay, so pi over 4, I would go -2.8, but it's not going to be over here. I'm going to run across the other side, so it's going to be, oh, look at that. It's that dot right there. Okay, what if I tried pi over 3? What is cosine at pi over 3 going to be? 1/2. What's -4 times 1/2? Oh, it's -2. So if my angle is pi over 3, it wouldn't be 2, it'd be -2. Oh, it's that dot right there. And then the last one, if I plugged in pi over 2, cosine at pi over 2 would be 0. -4 times 0 is 0. So up here at pi over 2, I'm back to 0. That is why I'm getting this graph right here. Okay, it's giving me the bottom half of that graph because those are the points that I get when I plug them into my equation. Okay, let me show you one more thing here. I'm going to slow this down. Again, if you change your theta step, it's going to slow it down quite a bit. I'm going to make it like 0.005. Watch my screen. It's going to go somewhat quick. See where it started? It started over here at 0 and then worked its way that way, just like we said. It's not just a semicircle, but it's where it started matters as well. Questions on something there in Bellwork? That's what we're going to do in the next couple days. We're going to understand better about what that is and where it comes from. Today's a pretty easy lesson in that it's on you to kind of explore what's going on. I'm not going to stand up here in front and tell you what's happening. You're going to figure out what's happening on your own. Okay, so here's what I want you to do. We already did this first thing. These are the steps to graphing up here on the top. Make sure you're in polar mode. Yeah, we've done all that. Okay, adjust your window. So we just did some adjustments. My suggestion for this activity is for this to be your window. You can be fine with what we set. We set -6.7 and 6.7. That's fine. But change your theta max, theta min 0, your theta max 15. That's just how far you're graphing it. So you're graphing more than one circle there. So it'll look like your computer's or your calculator's going a little bit longer than it needs to, but it's doing it right. Theta step 0.1, just so it doesn't take us forever here. Everything else is kind of the same. Again, here is that theta button we're using. Here's what I want you to do. This is an activity you're doing with you and your neighbor. Okay, you're using your graphing calculator. I want you to type this equation into your calculator, r equals 2 sine theta. And then you've got 6 categories that equation can go into. When you graph it, you're looking at your pictures. Is it a circle? Is it a cardioid? Is it a limason? Is it a lemniscate? Is it a rose? Or is it a spiral? It is your job to look at them and identify and categorize. Use your brain. I'm not going to give you the answers right away. I want you to think about it. Once you complete the front side, Then you are going to the backside and you are answering some different questions. Again, you're going to graph some stuff and then use your brain and try to answer the questions based off of what's given. Okay, when you're all the way done, call me over. I'd love to come over and talk with you about what you did and what you figured out. Everybody understand what you're doing?
Yeah.
Go. All right, let's see how we did. I know you might not have been all the way done, but we were doing some exploring. See if you agree with me. Up on the board, you've got your different graphs. Look at those first 7. See if you agree. See if you have any questions you'd like to ask me. Questions on where you got those? Anybody have any mistakes there? Limassons and cardioids, they look pretty similar. The only difference between a limasson and a cardioid is going to touch the origin. A limasson does not necessarily touch the origin. We'll talk about that more on Monday. There is the other ones. I would say 14, not a true lemniscate, but it's got a lemniscate shape, so we went with that. It's kind of a bonus one. Questions with any of those? Once we've typed those in, the backside, we started talking about cardioids. You can tell that these two are cardioids because the leading coefficient and the constant are the same. So it says 4 plus 4 or 6 minus 6. When those are the same, that's when you're going to get a cardioid. How do they compare? Well, if it has sine in it, it's going to have y-axis symmetry. If it has cosine in it, it's going to have x-axis symmetry. And when you change those numbers in front, it changes the radii. It changes how big it's going to get as you work through it. So it changes the maximum. Questions on one? You don't have to have exactly what I have. You have something different, great. It was an exploration lesson, so don't feel like, oh, I had to have that. Okay, number 2. It was a rose. How many petals is it going to have if it says 2n or 2 theta here? 4, because it's double if it's even. If it said 5 theta, then how many petals is it going to have? 5, because if it's an odd number, it stays that way. So this would have 3. This one would have 8, because it's 4. It's even. We double it. Okay? How does the leading coefficient change it? It makes the radius bigger. Again, y-axis graphs are going to have, sine graphs are going to have y-axis symmetry. Cosine graphs are going to have x-axis symmetry. Find an equation with 9 petals. I said 3 sine 9 theta. You could have anything there as long as you have a 9 in front of your theta. How can you get 14 petals? You can't, because if it had 14 in front of theta, you would double it. It'd be 28. If you had a 7 in front of theta, you would keep it the same and get 7. What is another number amount of petals that you cannot get? 22. You could not get 22 petals. What's another one? 6. Any number that when you cut it in half, it gets you an odd number. So an even number that when you cut in half gets you an odd number, you can't get that. So 6 or 10 or 14 or 18 or 22 and so on. Last one was a limaçon. A limaçon, you can have a limaçon without a loop or a limaçon with a loop. Okay, and we'll talk about that more again on Monday. I say it looks like a peach. Okay, we'll talk about that again in the future with loops or without a loop. It just depends what causes the difference in the shape. Which number is bigger? Is the constant bigger or is the leading coefficient bigger? That is going to change what that thing looks like, whether it has a loop or whether it doesn't have a loop. And again, we will do that more in the future. Questions with something we did today? Did pretty good. Here's your homework. Okay, your homework for the next 8 minutes. I want you to play on your calculator. Make the coolest looking graph that you can make using what we learned today. Okay, play around, hit some buttons, see what you can do. Go.